So next, let's look at misleading graphs. Yeah. So when you have a graph, often you have also people that are producing misleading graphs to mislead people, or you might produce a graph that is misleading by accident, or you can also have a representation of data and information which is misleading if you're not explaining it. And as you can see here, now we have the different projections of the countries and sizes of the world map. So with this Mercator representation of the world, we are overestimating the size of Greenland and the size of all of the countries and areas which are at the North or South Pole. And so you have to keep that in mind, that Russia, for example, is way smaller than it appears, also the US, and especially the countries which are more towards the middle of the map, so Africa and Europe. Those countries are not that, so they are larger compared to this very large countries like Greenland and so on. So this is not only a thing of maps, although the map presentation is very easy to understand, but this can also happen with other graphs and other visualizations of data. And as I already mentioned, so if you have axes and scales and you are modifying, for example, the y-axis, so the numerical, the quantitative axis of your chart, especially if you have bar charts, if you have areas, then look at the two graphs here. So the left graph, which is not cutting the y-axis, is giving you a different picture compared to the event attendance on the right side. Yeah, where you now would have the impression that the green bar fits 2 times into the blue bar and 3 times into the yellow bar. While looking at the left gives you the information, okay, it's round about the same. So stop the video now again with this question here. So which chart has the steeper rise, A or B? And try to answer it just based on looking at it really fast. So stop it now and decide. Yeah, okay, obviously, as you can see, chart A and chart B are the same. So they are representing the same data, but chart B, there you have a cut of the y-axis, and now you see, okay, it appears way steeper, although it's just the same. Yeah? Both contain the same data, just the point of view was modified and changed. And so this can also be called damper. Yeah. So values and magnitudes appear less than they are when you expand or compress the y-axis or the numerical axis. And for example, population more than tripled in the US between 1910 and 2020, based on the Census Bureau. The damper makes the increase look flat. Yeah, so you can just increase the y-axis, and that way it looks like quite okay. So there was no real increase. Just because you were choosing a different scaling of the y-axis. Yeah? So you did not cut the y-axis here, but you are distorting it by increasing or lowering the axis size, which is also not good. So the cherry picker would be, for example, like in this case on the left, you see just a cherry picking of data. Yeah. So the full scope and the context do not matter as long as the cherry picker has its way. Yeah, you're just picking the part of the data that is like fitting into your narrative and fitting into your storyline, and but that is also distorting. So if you look at the left, you would now say, okay, who wears glasses? So all the people wear less glasses than younger people. And if you look at the right, you see, okay, this is not right. Yeah, you see that also that the data is like quite fluctuating, but overall you see a trend that all the people wear more glasses, which is quite obvious. The smooth operator on the other side can use statistic tools to smoothing, so moving average and so on. Yeah, local regressions. You can use them to ease data so that it looks more, yeah, that it is smoothed. Yeah, smooth out noise, which is nice. Yeah. Sometimes it makes sense, but if you take things too far, and you can hide signals. Yeah. If you now look at the two again, you see on the right chart there is a little bit more movement. On the left, you see a steady rise in the percentage of people who wear glasses as they get older, and yeah, and you would that way remove all the bumps and forces a narrow age range on the y-axis. So this is also manipulating a little bit the impression of then the audience. So you have to keep in mind, smooth operator might make sense in some cases, but also don't take it too far. So the overbinner is doing something comparable like the smooth operator. So you clump things together into more general groups. And if you now look at the left, so you see again, okay, the height in inches and the NBA players. So you have a higher number of very small players compared to very large players. And if you look at the right, you have more bins, and you see, okay, you have a peak here, but you have you have some players that are a little bit smaller, but the larger those players get, the more they are, which makes sense because basketball players are obviously often very large, and so yeah, if you only reduce them to two groups, then you might also distort the results here. The base stealer now would be with a complete disregard of how charts work. The base stealer shortens the y-axis on a bar chart. As I explained before, so we are starting with the left chart at 40%, it's going up to like 45%. But that way you would say, okay, now male and female are quite different, yeah, if you look at the US population, but if you look at the right, it's like 50-50, yeah. So that's again this cutting of the y-axis and distorting results. Also, this is about the proportional link that we mentioned in the chapter before. So if we look at the time gap, again, we see on the left side, it looks like, okay, over time, here the data was quite rising, yeah. But if you look at the right one, you see, okay, you had a sharp increase in the beginning of the data set, but then it stabilized a little bit, you had another increase, and then it decreased over the last years till 2017. So the time gap is a variant of the cherry picker. You just choose points in time that properly fit to your storyline that you want to tell. Yeah. So this is here with a baby's name Nathan, and you see a boom here, but you also see that the name is not quite as popular as it was before. So the time gapper can also be combined with the overbinner and so on. So there's also a combination of different misleading tactics. So the storyteller can now combine some of those strategies. Yeah. So one can tell many stories with the same data set. There's also a German saying that vertraue keiner Statistik, die du nicht selber gefälscht hast. So don't trust the statistics that you did not manipulate yourself, which is on one side correct, on the other side it's not correct. So if you look at the data is always the same. It's just about the visualization and representation of the data. So you have to be really careful that you don't mislead your audience, that you don't fall into some of the traps. You have to present the data you have, and you don't present the data you want. Yeah, and so don't try to visualize something and interpret something based on the data which is not there. Yeah, this is bad scientific practice. Do good scientific practice and always highlight also your limitations. Your results are good because you did the experiment, and also non-positive experiments are positive experiments because you now have more knowledge, yeah? And so present what you have, and that's fine, and that's enough, and it's good, yeah. So, but to look at the storyteller here, yeah, the storyteller leads with a narrative and wants to show something, yeah, but instead do it the opposite way. You have the data and now tell a story, and don't start with the story and fit the data to the story, yeah, which would be bad. In this example here, for example, by shifting ranges of the x-axis and the y-axis, it's easy to change the story and what it is telling, yeah, because all of those graphs are quite different. There are also other types of misleading graphs, and also other types of manipulating with data visualization. So the faker, obviously, so you just come up with data, which is always not good. Yeah, as I said before, if you have the data and you visualize it, you at least have the data, so someone can reproduce what you did. If you fake the data, this is very bad scientific practice. And actually, if you do that in a thesis, this is very problematic. Yeah? This can also destroy your reputation, so don't do that. Yeah? If you go down that road, this can destroy your reputation for life. So the faker is one of the worst examples here. So just coming up with data, just inventing data, which is not bad. The descriptor on the other side is showing exactly the same graph. I'm just saying, okay, the information is, okay, this is horrible, but this is just a subjective interpretation of the data. And you could just say, okay, this is wonderful, yeah. And both times you're like, okay, why? Yeah, you have to always indicate also based on the data why it is good or why it is bad, or what you're interpreting based on your results. And the descriptor is just throwing out information and saying, okay, this is my interpretation, even though you cannot reproduce it based on the data visualization. When talking about misleading graphs, you can also mislead by using different color scales. So you have mainly 3 different color scales. So sequential, which is like different shades of blue, and you can see there's a logic from light to darker. You can have diverging, which are like yellow and blue are quite on the opposite ends of the color scale. So you can also see, okay, if you move between the both ends, this also gives you an indication, okay, where you are within a range. And you can have the categorical colors, which are just different, yeah, because you have categories which are not near or far away from each other. So you should use sequential or diverging for numerical data, for example, yeah, and categorical for categorical data. But be cautious to use, for example, sequential or diverging information if you have categorical data, yeah? Because that way you can also mislead that there is an influence between the categories, or vice versa, that there is no relation between the data points if you use categorical color scales. So stop the video again here. We are now having another question. Yeah, stop the video and look at this pie chart of vehicles owners by gender in Germany, and tell me who owns more vehicles, male or female persons. And stop the video, answer the question, and we see each other in the next slide. So the answer is obviously more male persons. And I wanted to give you this pie chart here because we often associate blue, especially light blue and pink colors, with gender. So if you are talking about gender, it is yeah, quite bad style using colors. So you're reproducing stereotypes, yeah. But if you are thinking, okay, hey, I'm clever, I'm just using blue for female persons and pink for male persons because I don't want to reproduce stereotypes, you're misleading people. Yeah. So also think about it. Maybe you don't want to reproduce stereotypes, but on the other side you also don't want to mislead people, then just use different colors. Yeah. So for example, the same as with political parties. They have a certain color scheme. Yeah, with the colors of political parties, it might not be a problem because they don't have really a stereotype. But if you're now using black for the Green Party, so people will ask, yeah, why did you do that? Yeah, this is just misleading. So think about what colors you are using to not reproduce, for example, stereotypes. Yeah, so for example, with the pink and blue, which is one of the most prominent examples in our modern Western culture, these colors have a stereotype baggage. So pink means weak, shy girls who play with dolls and don't deserve as much as boys. Blue stands for boys who need to be strong and rough. And when we create a chart with pink and blue, we endorse those gender stereotypes. Yeah. So especially when you are talking about, for example, gender pay gaps or something like that, that's quite the opposite of what you want to achieve. So color association and stereotypes are important because they can also lead to real world impact. So for example, with blue and pink, you have the pink tax, which indicates higher prices for pink products just because they are for women, and that's a type of discrimination. So choosing your colors of your chart can have real world impacts. And yeah, so by the way, also the social association of blue and pink, what's really introduced in 1950. So before that, yeah, both colors were used for both genders. So those biases and stereotypes are quite new in our society right now, and they are a societal decision. Yeah. And you can now look at the two representations here from the New York Times, which are doing it in a very nice way, in my opinion. So they are using different colors for the different genders. In one representation, you still see a woman's performance and valued 3% less. So this is the development of the of who gets a promotion and who doesn't, based on gender. And in the bottom, you see a representation of the genders within the different teams of the different, I think it was senators. So if you want to look also at those data visualizations, the New York Times is doing very good data visualizations and are very aware of stereotypes and which colors are associated with what. So feel free to also look at those interactive simulations. And it's not only about stereotypes, but also colors have different meanings. So please again stop the video and write down the answer for yourself. So please arrange the following areas in order of size and starting with the smallest. So you say, okay, whatever, the blue one is the smallest, so I say this is 1. The green one is the second smallest, the 2, until the largest, which is 5. So write that down and really think about that, stop the video for that, and then we meet each other on the next slide again. So now maybe this is surprising to you, it was surprising to me. If we look at colors, different colors have different representation. Yeah? As you can see, the red and the black squares are both the smallest, yeah? Which was surprising to me, because if you look at them, I don't see them as the same size. Yeah? And the gray one is the largest, even though with the gray color it might be a little bit, I would have suggested that the green one is the largest, yeah, and not the gray one. So, but the colors have different, different colors with different color gradients grab more or less room. So keep that in mind, and that's, by the way, also why those bubble charts are a little bit problematic, because if you use now different colors, you don't really can compare them, because you cannot put them next to each other. So when choosing colors, be aware that they might be seen with different grabbing of room in your chart. If you're comparing different colors, you have to set them next to each other within one axis, for example, so you can compare them. That's also a problem with pie charts, for example, yeah, with bubble charts and so on, where you cannot like put a ruler and compare the size of them. So an example of using labels and titles is this one here. So when you are describing your chart, and when you want to give more information, you have to include labels and titles. Yeah? So labels and titles is describing, for example, your axis. Yeah? Check out this live burst graph from Flowing Data. By the way, on Flowing Data you find a lot of good graphs. And you can now see how much value the annotations add. So for example, they added here details to the highest and the lowest point on the graph, which is quite nice, because that way you are describing the extrema of the data. Yeah? They explain why the baseline starts with 0%. So what is the 0%? It's the reference point in 2003. And as this is not quite obvious, they explain it, why they are starting in 2003 and what the 0% is representing. They also provide a caveat and an explanation for the 2021 data, and they reinforce in words that the percents on the y-axis show more births and fewer births. So they also describe, okay, what are you seeing on the different axes? Also, when working with data and doing those annotations, keep in mind use units. Yeah, indicate units. So for especially SI units, so stick to the international units, which are understandable. Yeah, they give you clarity. You have a global comparability. You avoid conversion errors, for example, also. Yeah. And often they are also required by standards or by journals. And so, for example, if you have labels, so at first always use labels, and then you can write, for example, in the label, okay, this is production in kilotons per year. So use also those SI prefixes and don't use ambiguous terms like booleans. Yeah, instead use G or the scientific notation side. Yeah? This also saves you a little bit of space, and yeah, also is established now. So also keep in mind you are starting with lowercase k. So the big K, so to say, is Kelvin. Yeah? So don't write big K for thousands. So it's always a small k, so lowercase k for thousands. So keep that in mind, because a lot of people out there are writing, for example, 45 Kelvin vehicles, which does not make sense at all. Yeah? And so to not fall into the trap, really look into how you annotate data and how you set up your labels and how you write down your units. And why does all of that matter, what we learned now? Yeah? Why does it matter? So we have a lot of data in the wild. You might find a very nice and cool data set, but you cannot work with it. Yeah? So you need good design practice. You need to avoid confusion. You need to avoid a deception. And then in the end, you have effective data visualization where you can then draw information out. And you can then base your results on those information and interpret those results, and then produce new learnings. Yeah, and so learning how to visualize data and how to also assist your storyline with data visualization will help you not only within maybe the thesis project, not only within your academic career, yeah, but it will also help you yeah, for your whole life, and also it will help you to understand if someone else is visualizing data, to see how they did it, and to interpret the results, and also to see the limitations of it.